Hello! Welcome to the KubeCon Cloud Native Con Europe 2020 virtual event. I'm Daniel Feldman, and the title of this session is Save Your Services from Sneaky Snoops with SPIFFE. First of all, I'd like to start by introducing myself. Again, my name is Daniel Feldman. I live in Minneapolis in the US, and I've been working on cloud security engineering for most of my career. I started out at a company called Veritas, which makes the #1 used enterprise backup software, which has a lot of really interesting security requirements. I worked on the security protocols team at that company. That work led me to join a startup called Scytale, which developed the SPIFFE and SPIRE open source CNCF security projects that I'll be discussing today. Then, just recently, Scytale was actually acquired by HPE, which is the #1 manufacturer of servers in the world and has a variety of really interesting open source projects. So I'm really excited to be continuing to work on SPIFFE and SPIRE at HPE. But I'm not just here to represent myself. There's a huge team with security experience at a variety of top companies that's working on SPIFFE and SPIRE. In fact, one of our founding engineers, Evan Gilman, was the author of the book Zero Trust Networks, and he'd probably be here today, except that he's out on paternity leave. So congratulations, Evan. Here are the subjects we'll be discussing today. First, what is service identity and why is it an interesting problem to solve? Second, we'll be discussing several different approaches to service identity that you might already be familiar with. Third, we'll be discussing SPIFFE, which is the standard for service identity. Fourth, we'll be discussing SPIRE, which is the implementation of SPIFFE that I work on every day. And then fifth, we'll be discussing the next steps for using SPIFFE and SPIRE at your company and contributing back to open source. Why is service identity an interesting problem? Well, you've probably seen charts like this before. Each one of these dots is a service at Netflix. All of these services are chunks of code that are then deployed in multiple clouds, multiple regions, maybe on CDNs, and they're all communicating with each other. And they're all constantly changing. Developers are constantly updating the code and changing how these services interact with each other. In order to do any kind of security, each entity that you're trying to secure has to have some kind of identity. For example, to encrypt something, you have to know the identity of the party that will be decrypting it. In order to ensure data integrity, if you're adding a digital signature, you have to know who will be verifying the digital signature and how they'll access your public key. In order to do authentication, obviously, the thing that you're authenticating has to have some kind of identity. And in order to do authorization, you need to first do authentication, and authentication depends on identity. For humans, identity is mostly straightforward. Each human is a unique individual. Humans don't clone each other. They don't constantly change. They have memories. You can give a human a username. You can give a human a password. You can give a human a two-factor authentication device and expect them to retain that information. For services, the situation is much more complicated. Services are constantly scaling up, scaling down, moving around, changing completely. They have no long-term memory. When a service starts up, how is it supposed to know what its username and password is? So solving the service identity problem is very important in order to be able to do any kind of security for connections between. Back in the pre-cloud days, we used to use perimeter security. In the perimeter security model, everything inside a perimeter is trusted and everything outside is untrusted. So you have a firewall, you have a DMZ that allows connections that go through the firewall boundary, and then all the services inside the perimeter are essentially trusted. They can all talk to each other. They don't require any credentials within the perimeter. As you add multiple data centers, multiple clouds, multiple regions within clouds, this becomes increasingly complex to maintain. You need really complicated firewall rules to allow specific connections from service A to service B to service C. And then as you add in developers, throwing in new code constantly with continuous integration and continuous delivery, this gets impossible to maintain because the connections between services are constantly changing. And as these systems get more and more complicated, there are more and more holes in the perimeter that a hacker can exploit. Can we just use shared secrets? Well, this is what you're probably using today if you haven't heard of SPIFFE yet. In the shared secrets model, every service has credentials or certificates that are used to access other services. Hopefully, these are all stored in a secret store, maybe Amazon's secret store, maybe HashiCorp Vault, maybe Azure secret store. But maintaining these secrets is hard work. You have to rotate them frequently. You have to make sure they're not being misused. You have to make sure that they aren't being stolen by insiders, by hackers from the outside, and then you're really reducing the problem to a different question, which is how do you authenticate your service to the secret store in the first place? And there's no good way to do that. Usually you just have some kind of a token that's in your config map that authenticates your service to the secret source so it can get other secrets. This is really a hack mapping username password authentication for humans onto services, but it doesn't work very well. Before we move on, it's worth asking why we can't just use Web Public Key Infrastructure, or Web PKI, to secure our internal services. Web PKI works great for securing access to our bank accounts, so it should work for internal services, right? Unfortunately, Web PKI is just not a great fit for internal services. In Web PKI, your browser requests a hostname from DNS, and DNS gives it an IP address. Then your browser connects to that IP address and receives a certificate signed by a certificate authority indicating that that server really owns that hostname. So Web PKI is really about establishing a strong binding from the DNS name of a service to the actual service itself. Unfortunately, internal services typically do not have an individual, globally recognized DNS name. You might have a service with thousands of copies. They might all have different host names. Or you might have one service that only has an IP address. It doesn't have a host name at all. Even if we could solve that problem, there would be no way for an instance of a service that's just starting up to find out its own identity. So Web PKI just doesn't fit well with solving the internal service identity problem, and we don't see it used very often for that application. So if you think about the solutions we just discussed, perimeter security, shared secrets, and Web PKI, you'll realize that what we really need is a way to securely distribute identities to services without depending on any manual effort, without depending on any external services like DNS or a secret store. And that method is SPIFFE, the Secure Production Identity Framework for Everyone. That's what we're here to talk about today, and that's what I work on. SPIFFE is a platform-agnostic standard for implementing service identity. It's inspired by internal software that was developed at Google, Netflix, and Facebook, and people from those companies got together way back in 2017 to start drafting the SPIFFE standard. SPIFFE gives your service a passport for communicating with other services. It doesn't actually do the communication. It's not a service mesh. It's not an overlay network. It just gives your service the identity information it needs to establish connections within those other systems. But it is partially implemented in several different service meshes. Then the full implementation is called SPIRE, and that's the reference implementation. That's the code I actually work on. But other software is free to implement SPIFFE. The SPIFFE standard consists of 4 different pieces. The first piece is SPIFFE IDs. SPIFFE IDs are a standard format for identifying services. It starts with SPIFFE:// it looks like a URL, and then there's a trust domain field. That's a unique identifier for your organization. Typically it's just your organization's top-level domain. And then there's a slash, then there's an identifier for the service. It's very simple. The next piece of SPIFFE is SPIFFE verifiable identity documents. These are cryptographically verifiable documents asserting that a service has a specific SPIFFE ID. We actually support 2 different formats for SVIDs. One is X509 certificates with certain fields filled in to include the SPIFFE ID. And the other is JavaScript web tokens, again with certain fields filled in to assert a specific SPIFFE ID. And you may want the X509 certificate or the JavaScript web token in different situations. The next piece of the SPIFFE standard is trust bundles. These are sets of certificates that can be used to verify the SVIDs, and the SPIFFE standard provides a format for the trust bundles and then a way for a service to get the list of trust bundles that's available. Finally, the SPIFFE standard includes the workload API. This is a very simple local gRPC API that allows your service to obtain its SPIFFE ID, its SVIDs, and its trust bundles, and then use them to establish secure communication later on. Why is it a local gRPC API? Well, if it was a remote API, it would need some kind of authentication. And when your service is first starting up, it doesn't have any kind of identity, so it can't perform any kind of authentication. So as part of the specification, we guarantee that this local workload API is available. Here's another diagram of the SPIFFE standard. You have a SPIFFE provider, which is providing those 4 elements of the SPIFFE standard to each of your services. Each service gets a SPIFFE ID, an SVID, a trust bundle, and access to that workload API, which lets it obtain the SPIFFE ID, SVID, trust bundle, and also notifications whenever any of those elements change. So there are a couple of different implementations of the SPIFFE standard that are available right now. Some of the service meshes, including Kuma, Istio, and Network Service Mesh, implement SPIFFE to varying degrees. And then the official reference implementation is SPIRE, which is the implementation of SPIFFE that includes the entire API, and it is production quality software. It's in use at a number of big companies right now. It's at the incubation level in the CNCF structure, so similar to Envoy or etcd. We're trying to get it up to the graduated level in CNCF, but that may take a little while longer. And it's available on GitHub. You can download it right now and see the open issues and contribute back up to it. I and many others work on SPIRE every day. SPIRE consists of two parts. The SPIRE server is actually responsible for signing the SVIDs. Because it needs to be highly secure, we recommend running SPIRE server on an isolated virtual machine or even on dedicated hardware within your data center. Then the SPIRE agent provides the workload API, and that runs on alongside your services on individual nodes. The first step in getting SPIRE running is called node attestation. In node attestation, the node proves its identity to the SPIRE server. On cloud platforms or on Kubernetes, the node provides an instance identity document to the SPIRE server, and then the SPIRE server validates that instance identity document and grants the agent its own SVID. It's also possible to perform node attestation through pre-distributed certificates or using join token strings. Because the node attestation process is automated, as you scale up the number of nodes, each node can be attested automatically, so you don't have to do any manual effort as you deploy more nodes. Now that we have secure communication from the SPIRE agent to the SPIRE server, the SPIRE agent can provide the workload API over a local connection. As new workloads connect, the SPIRE agent performs another process called workload attestation. For each workload, the SPIRE agent checks that the workload's UID, image, checksum, or other characteristics match the expected values to give that workload an SVID. Remember, the SPIRE server actually creates and signs the SVID, but the SPIRE agent is local to the workload, and that's the only place where those detailed characteristics of the workload can be checked. Once node attestation and workload attestation are done, we have a secure chain of trust going from the workload all the way back to the SPIRE server. And it looks a little bit like this. You can have all these different workloads. They're all communicating with the SPIRE server, getting up-to-date SVIDs, and those workloads can establish secure communication between each other using their secure identities. It's important to remember that none of this is static. The bundles and the SVIDs are getting updated frequently. Workloads are starting up and shutting down. Nodes are starting up and getting shutting down. Typically, we actually refresh the SVIDs every 4 hours, so it's very frequent, and there's no manual effort needed. Everything is happening behind the scenes, automated by the SPIRE implementation. So, of course, running SPIRE in real systems is a little bit more complicated than the toy example we just did. First of all, most organizations will run several SPIRE servers side by side, 2 or 3 copies of the same SPIRE server for high availability. Second, if you have multiple clouds, you want them to be loosely coupled so that if one can't access another, the entire system doesn't go down immediately. So we support a feature called federation, which lets you have multiple SPIRE clusters that are exchanging their bundles periodically so that they can all exchange, all the SVIDs are compatible within both systems, but they aren't tightly coupled. They aren't constantly talking to each other. Third, we have a feature called upstream authorities, which lets you use an external CA to do the SPIRE root certificate signing. And this is really common for organizations that have some kind of compliance mandate to use a single trust hierarchy for their whole organization. Or maybe they want to use some kind of hardware security module like an HSM available in AWS to do all their root certificate signing. Or maybe they want a hierarchy of SPIRE servers. They want to have one master SPIRE server for the whole organization, and then lots of SPIRE servers for individual divisions within their organization. Now let's talk about some frequently asked questions about SPIRE. First of all, why do we need one SPIRE agent per node? And what counts as a node anyway? Do virtual machine hosts count as a node? Do Kubernetes hosts count as a node? And the answer is, remember, the SPIRE agent is providing the SPIFFE workload API. The SPIFFE workload API is a local API. It's unauthenticated. And then the implementation uses features of the operating system to identify the process that's connecting to that API, and then use characteristics of that process to give that process the right SVID. So you need at least one SPIRE agent per instance of the operating system. And again, we support Linux, we support BSD, we mostly support Windows, although that's not official yet. But whichever operating system you're using, you need one SPIRE agent per instance of that operating system. So a virtual machine host wouldn't make sense to run a SPIRE agent on because it doesn't have access to those operating system calls that let us determine which process is connecting to which socket. But a Kubernetes node running lots of pods is fine to have just one SPIRE agent because there's just one kernel, and that kernel can identify which process is connecting to the workload API, regardless of which pod it's in. What if the SPIRE agent is compromised? So I didn't discuss this in the presentation, but the SPIRE agent itself has really minimal trust. It can only issue SVIDs that are allowed to be issued by that node. So even if the SPIRE agent is completely compromised, even if a hacker gets in and tampers with the SPIRE agent, it can't simply request SVIDs for any possible workload within your organization. It can only request SVIDs for the processes that are supposed to be running on that node. Also, the SPIRE agent doesn't have any of your cloud credentials. All of that is stored in the SPIRE server configuration. So even though it probably isn't great if your SPIRE agent is compromised, because it can issue SVIDs that it isn't supposed to issue, it can't issue just any SVID for your entire organization. It can only issue SVIDs that are supposed to be issued by that node. Next, what about my old workload that I don't want to change? Remember, SPIFFE, you have to implement some kind of client for that workload API in order to get your SPIFFE ID, trust bundle, and SVID. Well, you can use a sidecar proxy in Kubernetes to implement SPIRE client. And in fact, there are several open source sidecar proxies that you can just use already. And also for Java, we've provided a jar that plugs into the Java TLS APIs at a low level. So you can use SPIFFE in Java without changing your code at all. You just need to change some Java configuration. And then when your Java application creates a TLS socket, it will automatically use SPIFFE to get a client certificate. How do I specify which workloads get which SPIFFE IDs? So in SPIRE, this is done using a concept called registration entries, and these are stored in the SPIRE database. The registration entries map the characteristics of a workload to a specific SPIFFE ID, and then SPIRE will generate an SVID for that SPIFFE ID when it needs to. So here is an example registration entry for a node. It says, if this node is starting up and it has this AWS tag database, then give it the SPIFFE ID corresponding to database. So these are little chunks of, it's almost like code that says, if something has these characteristics, give it this SPIFFE ID. Here's another example for a workload. It says, if the workload has the parent ID database, meaning it's running on the node with the SPIFFE ID database, and also has the UID payments, then give it the SPIFFE ID database/payments. And this kind of structure can be used to create SPIFFE IDs flexibly for all the services within your organization. And the specific, we call them selectors, things like AWS tag, parent ID, UID, characteristics of the workload or the node that can be used to generate the right SPIFFE IDs. Those are all defined in plugins, so you can even create new plugins that define new characteristics of the node that can be used in registration entries. Finally, what if the SPIRE server goes down? Well, every SVID is configured with a time to live, and it will continue working for that length of time. In our default configuration, we've set up the time to live to be 4 hours. So if your SPIRE server goes down, you have 4 full hours to fix it before SVIDs start failing. In a lot of organizations, 4 hours isn't long enough, so they make that time to live longer. They make it a week or 2 weeks. And that way, if the SPIRE server goes down, they actually have a good length of time to be able to fix it before connections between services start to fail. Now, of course, the problem with making the TTL longer is then you have a greater risk that an attacker will be able to get in and steal those SVIDs and be able to use them to make unauthorized connections to services. So there's a trade-off between uptime and security. One of the aspects of SPIRE that I'm most proud of is the growing ecosystem of third-party tools and plugins for using it in specific situations. The team at Bloomberg has written a plugin for SPIRE that uses a trusted platform module to do node attestation. So say you're running physical hardware in a data center and you order 1,000 new servers. you can do that no data station automatically using the secure unique identifiers that are built into those servers at the factory. They also developed Vault Auth SPIRE, a plugin for HashiCorp Vault that lets you connect to it using a SPIRE SVID so you can access shared secrets. This is very useful for organizations that are currently using shared secrets for communication between their services, but they want to switch to SPIFFE authentication gradually. Finally, GitHub has released Emissary, a sophisticated sidecar proxy based on Envoy that implements a client for the workload API and also flexible access control based on SVIDs. This lets you wrap your existing services in a fully featured SPIFFE client so you don't have to change a lot of code. I'm really looking forward to using this one in our own projects. Now that you've heard a basic introduction to SPIFFE, you might be interested in who's using it. Well, first of all, because SPIFFE is just a standard, parts of it are actually implemented in most of the major service meshes, like Istio, Kuma, NSM, Console Connect, Hamlet, or several other service meshes that are all part of CNCF. But as far as SPIRE specifically, implementing the entire SPIFFE standard separately as a first-class service, a number of big companies are using it within their infrastructure, including ByteDance, Uber, Square, GitHub, Bloomberg, Stripe, Anthem, and TransferWise. And because it's open source, there are probably others that haven't announced that they're using it. So this is very widely used software at this point. Where can you go to find out more? Well, you can go to our website, spiffe.io. We also host regular community days. These are quarterly events. They're online these days, of course, where members of the SPIFFE community present on how they're using the standard and propose various improvements and enhancements to the standard. And finally, we have a very active Slack. I'm always on the Slack answering questions about SPIFFE, and many others are too. And that's where you should go if you have questions about how to get started or ideas for improvements that make sense for your use case. We also have some more talks you can watch. I've linked to them in the PowerPoint that you can download. First, you can see an introduction to SPIFFE and SPIRE from Evan Gilman. Again, he's the author of the Zero Trust Networks books. Then we have another presentation that's part of KubeCon 2020, which is called Running SPIRE in Large-Scale Enterprise-Grade Environments. That gets more into the federation, high availability, upstream certificate authorities, that kind of stuff that you need to run SPIRE for truly large environments, like with tens of thousands of agents. Finally, I've linked to another presentation that's on our website called Building Zero Trust-Based Authentication in Healthcare with SPIRE, and this is actually a presentation from the team at Anthem Health Insurance about how they're using SPIRE to make their network super secure to protect healthcare data. Finally, again, we're part of HPE, and HPE runs its own annual conference. It actually just happened. It's all online these days, of course, and there are a number of SPIRE deep dives at that conference that will be very helpful if you're trying to learn more about SPIRE. Finally, again, we're on GitHub. You can just go to GitHub, see what the open issues are, maybe contribute a patch, maybe update some documentation. We can always use the help. So again, just to recap, we discussed why you need service identity. We discussed several different approaches to service identity that don't use SPIFFE, such as perimeter security, shared secrets, web PKI, things that aren't a perfect fit for the service identity challenge. Then we discussed SPIFFE, which is the standard that I work on. We discussed SPIRE, which is the actual implementation of that standard. And then we discussed next steps for adopting SPIFFE within your organization. Thank you very much, everyone, for your time. You can follow up with me on Twitter, on email, and we should have plenty of time for questions within this session. Hi, everyone. Hope you enjoyed the talk, and I'm here to answer a couple of questions that came up during the talk. The first question was, are there already established patterns to extend user authentication using SVIDs? And this is a really good question. We actually have a working group in the SPIFFE Standards org working on something called transitive identity, which is going to be a way for one authentication service to essentially prove to the rest of your system that a user has a particular identity. So it'll be a way to attach user information to SVID service identity. That's work in progress, and we're discussing a bunch of different ways to do it. and different trade-offs. So I'd really encourage you to get involved with that. But we're just working on it now, and it's not quite ready yet. The next question from Shyam Sundar. Will different instances have different SPIFFE IDs? Will the same application have a unique SPIFFE ID? If there's a deployment with 3 replicas, will it have 3 different SPIFFE IDs? And that's a really good question too. The easy answer is basically you can do whatever makes sense for your organization. There's no rules about this. And we do have organizations doing a bunch of different things. What I'd really recommend is just have one SPIFFE ID for all the instances of your service. And that way, when you scale out multiple instances of the service, they can all have the same authentication properties. But that's what's really interesting about SPIFFE is it's really flexible and people are using it in a bunch of different ways for a bunch of different needs. Next question from Natty on Slack. Would SPIFFE and SPIRE work for IaaS workloads, i.e. traditional servers and VMs? And the answer is yes. Actually, a lot of what makes this so complicated is because we're trying to support individual VMs that are outside of Kubernetes. So we support Kubernetes, but we're not super tightly linked to Kubernetes. And we also work on bare metal servers. We work on all kinds of different platforms. We have plugins that can talk to all kinds of different platforms. Again, I work for HPE. We're a server company. So we're working on some features that integrate with HPE bare metal servers as well. Next, oh, sorry, that's the same question. Another question that comes up really frequently is, can I use SPIFFE IDs to authenticate to my databases, maybe databases that are running in Amazon RDS or the equivalent on Azure or GCP? And the answer is yes, we have a way to do that. We can share all the root certificates, the root certificate bundle from your SPIFFE server in a standard format for OIDC federation. So then you can use your SPIFFE SVID to connect seamlessly to a database that's in some managed service that doesn't know about SPIFFE. That's something that I think is really useful because often the database security is really the weak point in a lot of environments. So are there any more questions? You can feel free to follow up with me on Slack or in the Q&A box on Intrado, I guess. And I'll be here to answer questions for a while. You can also email me or join the SPIFFE Slack. And again, thank you very much. I'm really happy to be here. I guess we're done just a couple minutes early. So thanks, everyone.